My sample test for Chapter 2 in 101. And please note that what I've given you as a sample test, is by far longer than the actual test will be. Okay? So don't panic by you see the length and worry about the amount of time you'll have. 18 feet, 2 yards. So 18 feet, and we have to make it into yards, and so we want the feet to cancel, and we want yards, and you should know how many yards are in a foot or how many feet are in a yard, and 3 feet make 1 yard, so the feet would cancel, and you get 18 times 1 is 18 over 3. 18 divided by 3 is 6 yards. And I'm going to want to see you showing the units for each of these, showing how it works, not just saying 6 yards. Show the units, show how it works. So we got 1 hour, 17 minutes, and 30 seconds to minutes. 1 hour times 1 hour is 60 minutes. So we got 60 minutes for that part. Then we got 17 minutes. I don't need to convert that. Plus 17 minutes plus 30 seconds. To convert that to minutes, I have to have seconds in the denominator and minutes in the numerators, and with the seconds to cancel, and see, is it 60 minutes make a second or 60 seconds make a minute? I think that's 60 seconds make a minute. So I have 30 times 1, 30 over 60, which I believe is 1/2 or 0.5. You could do it either way. So we get 77 and a half. Okay, 4.5 square yards to square feet. Some of you would like decimal, so I'll do that. 4.5 square yards. That means yards times yards. And we have to go to feet, square feet, or feet times feet. So we need the yards to cancel out. And there's 2 of them because it's squared. And we need feet twice. And 3 feet is 1 yard. 3 feet is 1 yard. That yard of the square yards is canceled there. And that yard is square canceled there. So we have to take 4.5 times 3 times 3 divided by only ones. So we get 9 times 4.5. 9 times 4.5, which is 40.5. Square feet. Or if you wish, 40.5 feet squared. Now we have to convert 34 cubic meters, meters cubed, to cubic centimeters. That means meters 3 times. So meters, meters, meters to centimeters. And you should know centi means 100. 100 centimeters make 1 meter. So we got to take 34. Those 3 meters are canceled there, there, and there. Times 100 times 100 times 100. 34 times 100 would put 2 zeros on. Times another 100 would be another 2 zeros. Times 100 again, another 2. And you could do that on a calculator if you wanted. So it's 34 million cubic centimeters, or centimeters to the third, either way. Okay? "10 cubic yards is a truckload of topsoil, and it is being purchased to cover 75 feet by 50 feet backyard with a ½ inch of soil." So we got to figure out how many yards that is. Well, first of all, we have 75 feet one direction times 50 feet times 1/2 inch. And we've got to convert this to cubic yards. So we can get the foot to cancel and go to yards. 1 yard is 3 feet. The other foot to cancel, 1 yard is 3 feet. So we got both of the feets to cancel. Now we got to get the inches to cancel. So we can go inches on the denominator. We've got to cancel. So it's got to go in the denominator, and feet in the numerator, and 12 inches is 1 foot. But then we got to get that foot to yards. So we got to go feet in the denominator and yards in the numerator. And the feet would cancel, and see 3 feet is 1 yard. So we're going to have 75 times 50 times 1/2 times 1 times 1 times 1 times 1. 75 times 50 times 0.5 for half. That's 1875 divided by 3 times 3 times 12 times 3. 3 times 3 times 12 times 3. That's 324, which is, and this is going to be yards cubed, because we got rid of the inches, we got rid of all the feet, and we got yards cubed. So let's see how much that comes out. Does it fill our truck, or is it we're going to have extra? Do we have enough in the truck or not? 1875 divided by 324, that's 5.78 yards cubed. The truck can hold 10, so I almost have enough to go a full inch thick instead of just a half, because that's only about half the load. Little, not quite enough to do an inch, but close. Okay. An airliner travels 45 miles in 5 minutes. What is its speed in miles per hour? 45 miles in 5 minutes. But we want it in hours, so I want the minutes to cancel. Minutes are in the denominator, so I got to go minutes in the numerator, hours in the denominator. So the minutes would cancel, and see, and there's 60 minutes make 1 hour. And so now I'll have miles per hour, and I got to take 45 times 60 divided by 5. 45 divided by 5 is 9. 9 times 60 is 540 miles per hour. Okay? Okay, now we've got a car that gets 28 miles per gallon. How much does it cost to drive 250 miles? And a gallon is 309. So we want to drive 250 miles. So we want to know how much that costs. So this, I can't multiply by 250 because then I get miles squared. I have to get miles canceled. If I put miles on the bottom, I'll get the miles to cancel and I'll get something per gallon. But it's not going to be miles per gallon or something. So I need to figure out how to do this. Well, I want to know how many gallons it will take to go that far. So I'm going to turn this one over. Instead of 28 miles per gallon, that's 1 gallon goes 28 miles. And then I'm going to go times 250 miles. And now the miles will cancel, and I will find out how many gallons, because the gallons will be in the numerator. So I didn't want it this way, even though that's the way they gave it to me. All right, and so that will tell me how many gallons, but then I have to get the dollars. So I want the gallons to disappear and the dollars to appear. So I put gallons in the denominator to cancel, and it's $3.09 per 1 gallon. So I'm going to get 1 times 250 times 3.09 divided by 28 times 1. So the numerator is going to be 1 times 250 times 3.09. That's 772.5 over 28 times 1 is 28. And this will be, only thing left is the dollars. So I have this divided by 28, which gives me $27.58 to go 250 miles. Okay? All right. Now, on this front page, I want you to show me all the units going on here. So you have to show me all this. You just can't say, okay, the answer is, because I kind of did it in my head or I kind of knew how to do it. I want you to be able to show how to do the units. Okay, now this is just some fraction stuff and or order of operations. We got to subtract 2 fractions. See, fractions, adding and subtracting, we need a common denominator. But what do I do about the mixed fraction? I have 2/3 and 1 is, well, how many thirds is 1? 3/3 and 2/3 put together. So that would be 5/3, changing it to improper fraction, minus 3/4. So let's deal with this. So what's the common denominator? I hope you're thinking 12, and so I need to multiply this one by 4, and 4, and this one by 3, and 3. So I have 20 twelfths, multiplying 3 times 4, twelfths, minus 9 twelfths, which gives me 11 twelfths. Now I have to add to it, and I hope you understand that. I want this in fraction. So this is the ones, this is the tenths place. We have 2 tenths, 2 dimes. So I got to take 11 twelfths and add 2 tenths. Now I can go for a common denominator in these, but 2/10 reduces to 1/5. So I could get the common denominator between 12 and 5 or 12 and 10. And 12 and 10, see, it might take you a little bit to figure this out, but 12 times 5 is 60, and 10 times 6 is 60. So I'm going to multiply this one by 5 and 5, and this one by 6 and 6, and I get 55 over 60 plus 2 times 6, 12 over 60. So I have 67 over 60. And I could reduce that, take 60 out of that. That would be 1 7/60. Want it as a fraction. Okay. Order of operations. So I made a really messy one here. Okay. Please excuse my dear multiplication division at the same time. Aunt Sally's same time, left to right on those. So do we have any parentheses? Well, I see a pair of parentheses here. So I can add those. That would be 5. So I'd have 9 minus 5. Now I have these big parentheses, and inside that I have parentheses. So I'm going to have big parenthesis 12 divided by 4, and then I have this parentheses, and this is subtraction and addition. I just go left to right when they're the addition and subtraction. So 5 minus 6 is -1 plus 2 would be 1. Okay. Now in here, I still have parentheses, so I can't do the 9 minus 5, which is very tempting. I have to do the inside, and I have division and multiplication. Multiplication and division are the same level, so I do them left to right. So 12 divided by 4 is 3. I figure that out first, times 1, which is still 3. So I have 9 minus 5 times 3. So I don't need the parentheses anymore because that's all simplified, but now I have 9 minus 5 times 3. Well, subtraction comes after multiplication, so I still got to do this stuff first. So I have 9 minus 15, which is 9 minus 15 is -6. Okay. 6. Suppose you want to put and carpet in a room that measures 18 feet by 22 feet. Ooh, I'll go this way. Longer. 22 feet. And the carpet you want costs $28.50 per square yard and comes in rolls that are 12 foot wide and at least 100 feet long. So it's going to be plenty long. We just got to be efficient on how we do it. You only want one seam. Well, if I do this way, if I do 12 foot, then I'd have 6 feet. I'd have one seam this way. If I do it 12 foot this way, then I'd have 10 foot. And it looks like I would be wasting less. If I go this way, this would be 6 feet, and I'd be wasting half of the 12 feet. Here I'm only wasting 2 feet. So I think I want to go this way. So the amount of carpet I'm going to need is going to be 12 feet wide by, it's going to be 18 feet plus another 18 feet. And I'm going to have leftover. But that's kind of what happens when you buy carpet. Okay? So 18 plus 18 is 36 feet. I'll write it this way, feet. And 12 feet. So that is 12 times 36, 432 feet times feet, or feet squared. But I need to do it in square yards because that's the price. So I need to get the feet to cancel and put yard. And 3 feet is 1 yard. That gets one of the feet. And then we got to get the other foot canceled. 1 yard is 3 feet. That cancels both of them. And I'll have yards squared. So I got 432 times 1 times 1. Yard squared over 9, no units. So if I divide by 9, I get 48 yards squared. Now showing my units, it's $28.50 per yard squared. So the yards squared cancel, and I take 48 times 28.5. Oop, I didn't do times 48, and I get $1,368 plus tax. I want to see the units being done, so that showing me how to do the units, not just kind of doing it in your head. Okay, and that's going to be the hard part for you guys. Okay. What does this number mean? It means we've got 4.2, since it's a -3, divided by 10 3 times. That's what it means to do. It's 4.2 times divided by 10 3 times. That's what it means. 4.2 divided by 10 3 times. And what is the value? So we have 4.2 divided by, and 10 times 10 times 10 is 1,000. And we get 0.0042. That's its value. Okay, now you're riding an exercise bike at a fitness center, and the readout says you are using 500, ooh, that's a lot, calories, capital calories, per hour. Are you generating enough power to light a 100-watt bulb? Well, a watt is 1 joule per second. So we got to convert this to joules per second. So 1 big calorie is small calorie, 1,000 of the small calories. That would get the big calories out of there. Now we have small calories per hour, but we want joules per second. So now let's go on here. See, how many calories is a joule, or how many joules are a calorie? Well, it turns out that and we want the small calorie to cancel, and joule and there's 4.19, according to your notes, is 1 calorie. So the calories would cancel. So now we're in joules per hour. And now we got to figure out if it's, get it in seconds. So we want the hours to cancel. Hours is the denominator, so we got to put it in the numerator and put minutes. And 1 hour is 60 minutes. Now we're down to joules per minute, but we need joules per second. So we're going to go get the minutes to cancel and put seconds. And that's 1 minute is 60 seconds. So now we're trying to see if we got over 100 watts. A joule per second is a watt. So we got the right units. So our numerator is going to be 500 times 1,000 times 1,000 times 4.19 times 1 times 1. 2095000 joules, and the seconds is 1 times 1 times 1 times 60 times 60, which is 3,600 seconds. So let's see, let's divide these and find out how many joules per second. 2095000 divided by 3600. I'm producing 581.9 joules per second, or 581.9 watts. Oh, I could do 5 light bulbs because it only takes 100 watts to do the bulb. I'm doing 500 watts. Okay? Okay? All right. Now we're on page, we got 2 more pages to do. That's only 2 pages and a lot of work. That's why I said it's too long for the test, but it's giving you lots of practice for what could be on the test. All right. How many square millimeters are there in 3 square meters? So that's 3 meters squared. And we got to get millimeters. So we want the meters to cancel and get millimeters. And we have meters twice, so we have to do it twice. And hopefully you got notes that tell you that milli means there's 1,000 of those little guys in 1 meter and another 1,000 in the 1 meter. So now the meters will cancel the 2 meters there. And we get 3 times 1,000 times 1,000 divided by 1, which is 3 times 1,000 times 1,000. 3 million millimeters. Show your work. How many milligrams are in 5 kilograms? 5 kilograms. And we want kilograms to cancel, and we can go to grams first. So 1 kilogram is 1,000 grams. And now we got to go to milligrams. So we want the grams to cancel and get to milligrams. And it's 1,000 milligrams makes 1 gram. The grams cancel, the kilograms cancel, and we get 5 times 1,000 times 1,000, or 5 million milligrams. Okay, we got a blood alcohol problem here, so remember how to do that. 8 ounce of whiskey contains 70 grams of alcohol. And it says 50% of that. So that is 35 grams if you take 0.5 times 70, or half of 70. So that's how much alcohol gets into the blood. So 35 grams in the first hour. And this is going into a 200-pound man who drank it and has 600 milliliters. And we want grams per milliliter, so we go 6,000 milliliters. And so this comes out to be 35 divided by 6,000, which is 0.0058 grams per 1 milliliter. But we need to know how many grams per 100 milliliters, because that's how blood alcohol is, per 100. So we multiply by 100 in the numerator and by 100 in the denominator. So that number times 100 is 0.58 per 100 milliliters. Which means the blood alcohol content rating is 0.58, very intoxicated. The supposition here, that much alcohol in a whiskey is quite a bit. 50% of it going in an hour, that's quite a bit. And by the way, it absorbs and absorbs the alcohol, so it'd lose 10 grams every hour. So it'd really only be, after an hour, it'd only be 25, and that would reduce this down some, but it still would be intoxicated. That was Pretty Song whiskey. Okay. So now you have to tell me your assumptions so that I know what you're thinking. So how many frogs would it take to cover a floor of the classroom? Well, depending on the size of your frog, I might choose a big frog so I don't have to do as many. So I'm going to say a frog covers 1 square inch. 1 inch by 1 inch. 1 square inch. Okay? Every frog's going to be that size. I might make it 2 just to make it a bigger frog, but I'll call it 1. 1 square inch per frog. But I probably want to write it the other way around. 1 frog per square inch. I could put it 2. 1, 2. I'm going to make an assumption. So that's my assumption. Now I got to make an assumption on how big of the floor is of the classroom. Oh, and I think our classroom is probably 20 feet. That's probably a little bit small, but I'll go 20 feet times 30 feet. It's probably bigger than that, but I'll go with that. So I got to figure out how many frogs that is. Okay, so I got to get these to cancel. So I'm going to have 20 feet times 30 feet, but the units are not right. So I got to take each of these inches that are squared here and convert them. So I want to get I'm going to convert these feet to inches. So I'm going to multiply by, I want the feet to go, and I want inches, so that it'll cancel the inches. And there's 12 inches in one of these feet. And then I got to do 12 inches is 1 foot in the other feet. So the number of frogs is going to be 1 times 20 times 30 times 12 times 12. Okay? I said state your assumption, so I'm stating the room size is this, and I'm stating this. Okay? So 20 times 30 times 12 times 12, and I get the room floor covered would be 86,400 frogs. That's a lot of frog legs. Okay. If each frog consumes 50 calories in a day, how many watts are produced in a day by all of the frogs in part A? So that's 86400 frogs times 50 calories per frog. So the frogs cancel. Now I have calories. And then I got to make it into watts, which I got to change calories to joules. So these are capital calories. So I got to go to small calories, capital calorie, small calorie. 1,000 of those makes a big calorie. Now I have calories. Now I got to make it joules. So I got a little calories to go and get joules. 4.19 joules is 1 calorie. So now I got joules. But I have to get per second, and this is in a day. So I now have to get time in the bottom, and this is 1 day. But I need it in seconds. So now I have to multiply by, continuing on here, a day in the numerator can be broken up into hours, 24 hours. Well, we're not into seconds yet. And hours needs to go, and that'll be 60 minutes. And we're still not in the 2 seconds. And so now we got to get the minutes to cancel, and that's seconds. 60 seconds is 1 minute. Minutes cancel. Hours cancel. Day cancels. All the others cancel, and I have joules per second. So finally I have watts. That's a lot of work. 6, 8. Get it over here where you can see it. 86400 times 50 times 1,000 times 4.19 times 1 times 1 times 1 and 1 here. So we've got the numerator of 8,181,008,0000 joules. And then in the denominator I have 24 times 60 times 60, which is 86400 seconds. And so the watt, that's joules per second, watts. So I just have to divide these. So I've got 1, 8, 1,008,0000 divided by my last answer. And that is 20950 watts. Again, this is a lot harder than the test will be, but I'm giving you lots of practice. Okay, 13. A country, in an effort to reduce the population, decided to adopt a one-son policy. Under the one-son policy, a family will have children, but their last child is limited to being a son. Determine what percentage of the population would be boys, assuming that the birth is equally likely boy or girl. Well, you could try to figure out for each family, but as we did in class on Wednesday, we talked about they're equally likely, so you're going to have girls and boys happening. It's just that when a family has a boy, they're going to stop having kids. So there should be equal number of girls and boys born. Because they're 50-50 chance of getting a girl or a boy. It doesn't matter that you stop with a boy when you're having your kids. Because some people will have a girl and a boy, some will have several girls and boy, but some will just have a boy and no girls. And it should balance out to be equal number of girls and boys. All right. Brothers and sisters have I none, but that man's father is my father's son. Who is that man? So let's pretend we're looking at a picture of people. And you're pointing at that man. So let's put a man here. I don't know how to make him look like a man other than let's just put a hat on him, which could be guy or girl, but let's get that man. Father. So let's put a picture of the father. I'll just make him a little taller here, and I don't know how to make him look like gray hair, maybe a beard like me. And there we go. So there's the father. And this is that man. That man's father is my father's son. So this person has got to be the son of this guy. So might be a different person, but wait a minute. Brothers and sisters have I none. So if he was a different person, he would have a brother. And he has no brother or sister. So that man, that father's son is this guy, and that man is the guy who's talking. Okay? All right. You have 12 gold coins that look identical, but you are correctly told that one is heavier counterfeit coin. Using a balance, so that's like we did for our boats, something that compares the weight of two things. The heavier would put it down. What is the minimum number of weighings or comparison of weights that would be necessary to find the counterfeit coin? So there's 12 of them. So I would put the first 4 with the first 4. If they balance, then none of these are the counterfeit. If they don't balance, the side that goes down would have the counterfeit in it. So I will know in this first weighing whether the counterfeit is here or here or here. So I've already narrowed it down to 4 without even weighing those. So now I have 4, and I think that one of them's counterfeit. So now how many weighings do I need to do? Well, I can't split up in thirds this time, can I? So I could either weigh just a pair of them. If they balance, the counterfeit's over here. Or if I weigh the other two, then and they're balanced, then it'd be over here. If it's in the one I weigh, then I would know which one's the heavier. So it could only take 2 if I'm lucky on this guess, but it could take 3. Now, is there another way to do it? What if I weighed 2 against 2? Well, then, whatever side goes down, I would know that's the heavy one is in there, and I'd still have to do another weighing to check. So I might get lucky on 2, but for sure, 3 weighings, I could have it. Okay? Do 4 against 4, and then do, say 2 against 2, and then I'll know which one has the heavier, and then I'll do that again. That would make it for sure 2. If I just did 4 against 4 and did 1 against 1, if I got lucky, I'd know I'd have the heavy one. If I didn't get lucky, I know it's over here, and I just weigh those, and then it would take 3. So I can do it for sure for 3, but I might get lucky and get it in 2. I don't think you can do it all in 2. But maybe you'll prove me wrong. Okay, classic problem here. You'll probably hate me for doing this, but 3 guests check into a hotel and pay $30 for a shared room. So here's my 3 guests. And they together pay $30. So they're short $30. They go up to the room, and a while later, the room was only $25. So the room's only $25. So now it's going to be $25, and they need to give the bellboy, he wears a hat, has to take $5 back to the 3 guys. Now, how much does each guy out so far? Well, they were each out $10. Now, the bellboy on his way back says, oh, they're not going to be able to split up the $5, so I'm just going to give them $3. So now each one of these is out $9, and the bellboy's got $2. Now, each guest has paid $9, which is $27, and the bellhop has $2 for a total of $29. But they paid $30. Where's the other $1? Well, the problem is on this one is we're not counting the same thing. Okay? What's going on here is there's $9, these are down. So that's a minus 9, minus 9, and minus 9. You don't want to add the $2 they got because that's a plus 2 this guy has. You want to go minus 9, minus 9, minus 9, which is minus 27. These guys are out. And you want to, the hotel is plus 25, and the guy is plus 2. making 27, these guys have, of the 27 they're missing. It's improper to add the 2 to the 27 and make 29 and try to figure out that's the 30. We're not adding the same things. So you would have to explain that to me if this was the test question. Okay, 17, and the last one in my here. 3 problem-solving techniques. Okay. One is to make a model, like I did with the cups in class or different things like that. One is to make a model, or a picture, or a diagram, so something like that. One is to simplify the problem. We did that when we talked about the cup of coffee and the cup of milk. We went to simpler things. We went to dice that were easier to look at. So simplify the problem. And a third, one problem-solving technique is to walk away from the problem and think about it. Just let it sit for a while, and your mind works while you're doing so. Take a break. See, another problem-solving technique would be, let me think here. Those are kind of the ones we have addressed a little bit in class. Let's see, what else did we do? Think outside of the box. That one, like the rope around the wrists. You can't take the rope off, but you can weave the rope around the wrist. So you got to think about, okay, it looks like it's the wrist and the rope are tied together and you can't get through, but you can get through if you think through that way. Okay, so you want to think outside the box. There's another one that I haven't given you that says you have 9 dots making a perfect square. They're all lined up. Can you draw 4 lines that are connected and hit all the dots? And I'll let you think about that one. A lot of people go there, that's 2, and they're connected. Then I go over here, and that's 3, and then they go up to there, and that's 4, and they miss a dot. Or they go this way, and they miss a dot. Or they try other things. This one's about thinking outside the box. Think about that one a little bit. Okay? Those are some problem-solving techniques. Take a look at 2C section for more ideas on problem solving. Okay?